So first of all, sorry I'm not here today. And just so you know, we're going to do our lessons a little bit out of order. Today you will take notes on lesson 4.4, and then tomorrow when I'm back, we will go back and do 4.3. So there'll be a couple of things that I reference in today's lessons that you haven't seen yet, but you don't have to see them to understand the material today. This is a pretty easy lesson, so I chose to teach it now when I'm gone versus when I'm there. I do want you to start off with solving this warm-up. So please, at this time, just pause the video and give it a couple minutes, and you guys figure out what X and Y are. Okay, so you hopefully were able to either just logically think through this, maybe you used guess and check, maybe you wrote a system of equations and then solved your system of equations. But no matter what you do, you should end up finding out that X equals negative 0.5 or negative 1/2, and Y equals 2.5, or if you'd like it as a fraction, 5/2. Now I chose to solve it by creating a system of equations. Each line represents an equation. X is means X equals 3 less than Y. That's saying here's Y. If I take away 3, that does equal what my X should be. So that's my first equation. The second equation says the sum. Well, sum means you're adding. So it's saying, hey, add together 2x and 4y, and is 4 means equals 4. So this equation becomes 2x plus 2y equals 4. And then if you go through your substitution method, this one's set up pretty nice for it because x is already solved for. If I use the highlighters like I did in class last week, x equals y minus 3. That means in the second equation where I see an x, I substitute this expression, and it becomes a lovely distributive property. So you have 2 times y minus 3, then plus 2y equals 4. Distributing your 2 means you get 2y minus 6 plus 2y equals 4. So this simplifies back down to a chapter 1 problem. You combine your like terms, because my goal now is to get y by itself. So I have to combine my like terms. My like terms are just the y values. So I'm just going to do these two, and I get 4y minus 6 equals 4. Getting y by itself, I add 6 to both sides. This gives you 4y equals 10. Getting y by itself by undoing that secret operation of multiplication with division. And so this gives you y equals this fraction. Now, if you're leaving it as a fraction, it needs to be simplified. So I'm going to start with that. 10 and 4 can both be divided by 2. That's how you simplify fractions. If you don't simplify fractions, you should know by now that you'll lose a half a point, either on your homework or on a test or quiz, no matter what. 5/2 does simplify down to the decimal 2.5. I find it easier that when I'm solving systems of equations, if I can work my numbers as a decimal, it makes it a little bit easier than if I'm working with them as a fraction. And so if your fraction does simplify down to a nice decimal, I recommend you do that and use that decimal instead of the fraction. Once I figured out my y, I'm going to circle it so I don't lose it. And then I was going to take this number, y equals 2.5, and I was going to plug it into one of my original equations. Now I'm going to plug it into what looks easy, and for me, this very top one looks the easiest. So I get x equals, our y value we decided is 2.5 minus 3. When I go through that subtraction, that's just negative 0.5. And those are my two solutions. Now, since I did not specifically tell you in these directions that this was a system, I'm not writing my answer as a coordinate point. If it does not say solve the system of equations, you can write your answer just as x equals blank, y equals blank, or whatever the letters are. Hopefully you got the same answers there. Next thing, let's open up to your notes section. These notes should go pretty quick. There's actually not a lot to it. After we do the notes, then you can work on the homework, Again, you can do the homework. It should go pretty quick. Ideally, you should finish your homework in class today or get pretty darn close to finishing it in class. And then if you finish that, please make sure the 2 homeworks that I am grading tomorrow are ready to go. That'd be 4.1 and 4.2. So priority is starting tonight's homework in class, and then if you finish that, make sure the homework that's due tomorrow is ready to go. Please make sure you ask for the video to be stopped at any point you need stuff to be written down. But here you go. This lesson title is 4.4, Special Systems of Equations, SOE. There's a little bit more below here that hopefully I can scroll. Yeah, I'm going to try and make sure this all fits on one page so you can just pause the video and get it all copied down. Okay, so Special Systems of Equations just talks about the different types of solutions we're going to have. We have one solution, no solution, and infinite solutions. At this time, please pause the video so everyone can get this written down. Great. So I'm just going to talk about it before we go past it. Special systems of equations. So the type of answers we can have. We can have a one solution. That means my system, my 2 lines cross once. The way we solve it is using one of 3 methods. We either graph the 2 lines and see where they cross. We use the substitution method that we learned last week before our long break. Or we can use something called elimination. This is new. This is what I'll show you tomorrow. Now, this is actually 4.3, the elimination method, and it's pretty involved, and so that's why I'm waiting to teach it until I'm actually back in school. But today's lesson, I'll reference elimination, but you don't have to know how to do it to figure out these types of answers. Just know that tomorrow you're learning that method. The other kinds of solutions are no solution. Now, if you remember way back in Chapter 1 and 2, we talk about things of no solutions, particularly in Chapter 1. A no solution is when we would solve an equation and we'd get something really ridiculous, like 0 equals 2. That's not true in any way, shape, or form. That would be a no solution. Well, if we're talking about a system, and systems are when 2 lines cross each other, a no solution would mean they never cross each other. And so the only way 2 lines never cross is if they are parallel. And if you forgot what that means, it means the slopes are the same and they have a different y-intercept. Now there's a couple ways you can figure out if there's a no solution. Yes, you could graph it. That's pretty time consuming. But the more common way to figure out if you have a no solution is looking at the slopes of the lines. Now this only works if you have the equation rewritten, so it's y equals mx plus b. If the equation is not given to you like that, rewrite it. That would be almost your first step every time until you learn elimination. So just start off right now. Anytime you see a system of equations, start rewriting them. Start rewriting them into y equals mx plus b. Because if you like the graphing method, then you have to do that anyway. And if you like substitution, well, one of them has to be rewritten that way anyway. Many ways you can solve this. Most common is just rewriting in slope-intercept and looking at the slopes themselves. The last type of solution we have is an infinite solution. Now, if you remember way back in Chapter 1, an infinite solution is when we solved an equation and we got something that was always true, like 4 equals 4. That's definitely true. There's no argument. If I have $4 in my hand, I have $4 in my hand. You can't argue with that. What that means with a system of equations is that the 2 lines are actually the same exact thing. So when I graph them, and you can kind of see what I did here, I graphed in 2 different colors. I graphed in a pink and a blue, and they're overlapping each other, which means they're the same exact line. And then 3 ways you can do it. You can solve it using graphing, substitution, or this elimination. Again, you don't even have to know too much about elimination to figure out if you have the same equation or not. Now let's actually see some problems. Now we're only going to do 2 of them. This really won't take too long. Okay, so let's continue here. One start note I'd like you to know that from here on out, pretty much, the directions are just going to say solve a system of equations. And you have all these different methods. You'll have all these different methods, graphing, substitution, elimination, and now you'll have different answers you could have. You could have this one solution. You could have a no solution. You could have an infinite solution. And it's kind of hard to figure out where should you start. Well, the first thing I recommend is to rule out if you have a no solution or an infinite solution first, because if you have one of those, then you're done. You don't have to worry about it because those don't take a lot of work. But if you have checked, hey, are the slopes the same? Answer's no. Okay, let's move on. If you have an infinite solution, if you see, wait a minute, these two lines are the exact same thing, then it's infinite solution and you're done. But if neither of those options work in your problem, that automatically means you have a one solution. I don't want you to just tell me there's one solution. I want to know what it is. So, if you have one solution, figure it out. What is that point of intersection? And then you can use graphing, substitution, or elimination that you'll see tomorrow to figure it out. No solution. I'm already telling you what it's going to be, but I just want you to be able to see the different ways that we can spot it. Now, I'm going to show you the more common method to decide if you have a no solution and the not so common method, which is graphing, just because graphing takes a while. So let's just say here, we got these two equations. You got y equals 3x minus 1, y equals 3x minus 5. My little star note says let's rule out everything else first. Well, it's easiest to spot a no solution because slopes are the same. So here, slopes are the numbers that are glued to your x when the equation is written as y equals mx plus b. If the problem is not written in this way, you have to rewrite it. It's the easiest step to take. Just rewrite the equation so y is by itself. Then you can compare your two slopes. In this case, the type of work I'm looking for is for you to tell me that you can figure out what a slope is. So here's our top line. The slope equals 3. This is the kind of work I'm looking for on your homework. Bottom one, hey, wait a minute, slope is also 3. So because the slope is the exact same, right here, slope is 3, I'm going to say they're the same. Computer's a little slow this morning, look at this. Which therefore means my answer is a no solution. So there's really not a lot of work to show if your equations are already written in y equals mx plus b. But if it's not, then you have to get it there. But what you'd write down as your final circled or boxed or highlighted answer is the fact that there's no solution. Now the other way that we can figure out this answer, that there's no solution, is using the graphing method. Now I say that's the least common method just because graphing can be kind of tedious. You're more likely to make a counting error when you're using your slopes and your y-intercepts, especially if you mix up where your y-axis is and where your x-axis is, which I do tend to see quite often. And so the first thing we're going to do is just graph it. I'll show you the graphs here. I'll graph the top line in blue. I'll graph the bottom line in pink. As a reminder, you always start that y-intercept. In this case, it's a -1. So here's -1. Oops, wrong one. It's supposed to be in blue. Here's -1. My slope is +3. Well, 3 is not a fraction, so to make it a fraction, I put it over 1. And since it's positive, from my y-intercept, I rise up 1, 2, 3, run to the right 1, and I stop and draw a point. I'm going to do it again, though, so I have a couple more points. Rise from where I left, 1, 2, 3, run to the right 1. And I'm going to reverse my slope so I can get some points down here in quadrant 3. That means I go back to where I started. Instead of rising 3, I fall 3. So I go 1, 2, 3, and I run to the left instead of right. Now that's enough points for me that I can connect them and have a pretty good idea what my line is going to look like. So there's line 1. I'll do the same thing for line 2. This time this y-intercept is at a -5, so I'm going to start there. Here's -5 on my y-axis. Slope is also 3. So I go up 3. I 1, 2, 3, run to the right 1 because I'm trying to make it a fraction. And I do it again. From where I left off, I rise up 3, 1, 2, 3, run to the right 1. Let's do it again just to be sure. Rising up 3 is 1, 2, 3. Running to the right is 1. And then you play a little connecty dots. Ooh, that was a bad one. Let's redo that. There you go. A little bit better. So now you can see from when I graph them, these lines actually aren't intersecting. I know my line is not perfect, it's not perfectly going through these dots, but you do get the idea. And the fact that you can already see why graphing is not the best method, especially if maybe you don't go through all your points with your line. It can give you the wrong idea sometimes, just depending on how careful you are when graphing. But you can see no matter what, our lines aren't crossing. So if I use the graphing method, I would still reach the same conclusion that there is no solution to the system of equations. Now you just need to do a rough sketch of that graph. You don't need to be super fancy. Again, please make sure you raise your hand and say, please pause this, or please rewind in case you missed anything. Moving on to example 2 is actually the last example of our lesson. I did not tell you what kind of answer we're going to have this time. Please write down the two equations. 4x plus 8y equals 36, and 12x plus 24y equals 108. Oh, man, these are kind of some big numbers. Well, the thing I have to make sure I do is rule out no solutions and infinite solutions, and then I can decide, hey, is there one solution? Awesome, let's figure it out. Sometimes you'll see a little pattern with the numbers. Now this is an introduction to what I'm going to show you tomorrow when we talk about something called the elimination method. If you have an equation written like this, so this isn't, both equations are in standard form. If you forgot what standard form is, that's when it looks like ax plus by equals c, and a, b, and c are just numbers. In other words, all the variables are on one side and you have a constant on the other. If you notice that maybe, just maybe, there is a number that you can multiply one of the equations by to get to the other, that is a telltale sign that, hey, I think these are going to be the same exact equation. I'll show you different methods, so if this one doesn't make sense right now, don't worry, you'll see the other ones. So let's just start with just looking at the x terms. I like to call this secret option number 3 to look at this pattern. If we look at our x terms and you see that all of our terms are lined up, x's are lined up one another, y's are lined up, normal numbers are lined up, what can I multiply 4 by to get to 3? Or, whoa, I just said the answer. 4 to get to a 12, it is 3. Hope you figured that out because I definitely gave you the answer. Okay, so if I multiply 4 by 3, I get 12. I want to know, is that going to be the same for all the other terms? So what can I multiply 8 by to get to 24? Well, wait a minute, that is also a times 3. Does it work for 36 and 108? Well, if you actually go through that multiplication, 36 times 3, and if you're not 100% sure and you do not trust this, actually set up your multiplication problem. 3 times 6 is 18. You put your 8 down, you carry your 1. 3 times 3 is 9, plus 1 is 10. So you have 108. So that works out. Well, right here, because I had to multiply every term by the same exact number, what that means is that these are actually the same equation. And if these are the same equation, that means it'll be an infinite solution. But you might not trust that. This might seem like hard to kind of wrap your brain around why that works. So let's show you the other ways that you can get the same exact answer. The way you do that is just starting with rewriting your equations so that it's in the form of y equals mx plus b. If we start with that top equation, you have 4x plus 8y equals 36, and you're getting y by itself, so you're trying to solve for. So you kick out your x first, and you do that with subtraction since 4x is positive. So I'm going to subtract 4x on both sides. Oopsies, too far. So that gives you 8y equals negative 4x plus 36. And then I have to get my y by itself, which means I'm dividing everything by 8. So I'm going to divide every number I see by 8. This gives you y equals, simplifying your fractions, negative 4 divided by 8, well that's just a negative 1/2. X plus 36 divided by 8. Now you can just go simplify those fractions, or you can put it into a decimal, which I would say probably easier. 36 divided by 8 as a decimal is just 4.5. So another way we can figure this out is, hey, is this equation that is now in y equals mx plus b, is it going to be the same exact thing as this bottom equation? Well, let's figure that out. We have 12x plus 24y equals 108. Kind of slow going here. Look at this. Same deal. I have to get my y by itself, so my first step is going to subtract 12x on both sides. That gives you 24y equals negative 12x plus 108. Same idea, trying to get my y by itself. So I'm going to divide everything, all my numbers, by 24. Can you see how bad this is lagging, guys? This is killing me. So let's get you y equals negative 12 divided by 24. When that simplifies down, that is also a negative 1/2, and then x tags along. 108 divided by 24. Now it might be easier if you just divide these numbers by a common factor and then use your division. But when you go through that division, no matter how you do it, whether you work with these numbers as is or you simplify it first, you do still get 4.5. So this is another method, if you didn't like my secret option number 3, to figure out if there's an infinite solution. You can just solve the equations for y and see if you get the same equation. And you do! They're the same! So no matter what, you still reach the same conclusion that it is an infinite solution. They are the same. I don't care what method makes sense for you. If you would prefer to solve the equations for y, do it. If you would like to use secret option number 3 and figure out a number you can multiply one equation by to get to the other, do it. I don't care. Whatever makes the most sense for you is what I want you to use. So if solving for y makes sense, go for it. Finding that factor makes more sense, go for it. Do what makes sense for you. I will answer any questions I can when I am back tomorrow. But here's your homework. You can hopefully easily go through this. This shouldn't have been too bad of a lesson, but if this still was confusing you, just please write down your questions and I'll answer them tomorrow. This homework is page 180 to 181, numbers 5 to 17 odd. I added this note in here. Please make sure you're ready to turn in the homework that's due tomorrow. That's 4.1 and 4.2. Please check your homework checkboard. The rest of the time, start this homework, and I'll see you guys tomorrow. Bye.